Using SO cord for a sustained load of 6 kVA may cause overheating and a fire hazard. SO cord is typically rated for lower amperage applications. The length of the secondary cord, at 3 feet, may result in a noticeable voltage drop, potentially affecting the performance of the machine. Hanging the transformer on the machine using the cord as a support can put strain on the cord and its connections. The secondary side of the transformer should have fuses installed to protect against short circuits and overloads. The primary side should be protected by a circuit breaker or fuses rated for the transformer's primary current. Replace the SO cord with a cord that is rated for the full load of the transformer, which is 6 kVA and is suitable for industrial use. Maintain the length of the cords, both primary and secondary, as short as possible to minimize voltage drop and avoid tripping the fuses. Install the transformer securely on a stable surface or hang it using a dedicated support bracket, not the cord. Ensure that the secondary side of the transformer is protected by fuses of the appropriate rating. Perform periodic inspections of the cords and transformer for any signs of damage or overheating. The secondary side of the transformer should be connected to a grounded outlet. The transformer should be installed in a well-ventilated area. Follow all manufacturer's instructions for proper installation and operation of the transformer. To delve deeper into the issues, let's start with overheating. SO cord, while flexible and convenient, is not designed for continuous high amperage loads. A 6 kVA transformer, depending on the voltage, can draw a significant amount of current. The current carrying capacity of SO cord is limited, and exceeding this limit can lead to the cord heating up. This heat can degrade the insulation, potentially causing a short circuit and a fire. To calculate the primary current, we can use the formula power equals voltage times current. In this case, 6000 volt amps divided by 480 volts gives us 12.5 amps. For the secondary current, 6000 volt amps divided by 240 volts gives us 25 amps. These values are approximate and don't account for transformer inefficiencies, which will increase the actual current draw. Consult the transformer's nameplate for precise current ratings. Next, let's examine voltage drop. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. It's influenced by the conductor's length, cross-sectional area, and the amount of current flowing through it. A longer cord and a higher current will result in a greater voltage drop. In the case of the 3-foot secondary cord, the voltage drop might seem insignificant, but it can still impact the performance of sensitive equipment. If the voltage at the machine drops too low, it may not operate correctly, or it could even be damaged. The formula for voltage drop is voltage drop equals current times resistance. The resistance depends on the conductor material, length and cross-sectional area. Using a thicker, properly rated cord will significantly reduce voltage drop. Now consider mechanical strain. Hanging a heavy transformer using the SO cord is not a safe practice. The cord is not designed to support the weight of the transformer, and it can put excessive strain on the cord's conductors and connections. This strain can lead to premature failure of the cord and potentially create a dangerous situation where the transformer falls. Always use a dedicated support bracket or mount the transformer on a stable surface. Fuses and overcurrent protection are crucial safety components in any electrical system. Fuses are designed to protect against short circuits and overloads by interrupting the circuit when the current exceeds a certain level. The secondary side of the transformer should always have fuses installed to protect the connected equipment. The primary side should be protected by a circuit breaker or fuses rated for the transformer's primary current. Selecting the correct fuse size is critical. It should be large enough to handle the normal operating current of the transformer and the connected load, but small enough to trip quickly in the event of a fault. Consult the transformer's nameplate and relevant electrical codes such as the National Electrical Code, NEC, for guidance on fuse sizing. When choosing a replacement cord, make sure it's rated for the full load of the transformer. Consider using a cord with a higher amperage rating than required for added safety. Also, Choose a cord that's suitable for industrial use, meaning it's designed to withstand the harsh conditions of a factory or workshop environment. Look for features like oil resistance, abrasion resistance, and resistance to chemicals. Minimizing cord length is always a good practice. Shorter cords reduce voltage drop and minimize the risk of damage. Keep both the primary and secondary cords as short as possible without creating strain on the connections. Securely mounting the transformer is essential for safety. Use a dedicated support bracket that's designed to handle the weight of the transformer. Alternatively, mount the transformer on a stable surface, such as a wall or a floor. Ensure that the mounting location is well ventilated to prevent overheating. Regularly inspect the cords and transformer for any signs of damage or overheating. Look for cracks, cuts, abrasions, and discoloration on the cords. Check the transformer for signs of overheating, such as a burning smell or discoloration of the enclosure. If you notice any damage, replace the cord or repair the transformer immediately. Grounding the secondary side of the transformer is crucial for safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or blowing the fuse and preventing electrical shock hazards. Ensure that the secondary side of the transformer is connected to a properly grounded outlet. Proper ventilation is essential to prevent overheating. Transformers generate heat during operation, and if they are not properly ventilated, the heat can build up and damage the transformer. Ensure that the transformer is installed in a well-ventilated area where air can circulate freely around it. Avoid installing the transformer in enclosed spaces or near heat sources. Always follow the manufacturer's instructions for proper installation and operation of the transformer. The manufacturer's instructions provide valuable information about the transformer's specifications, wiring diagrams, and safety precautions. Read and understand the instructions thoroughly before installing or operating the transformer. Regarding NEC compliance, several articles are relevant. NEC Article 450 covers transformers in general, including installation requirements, overcurrent protection, and grounding. NEC Article 400 covers flexible cords and cables, including allowable uses, ampacity ratings, and grounding requirements. NEC Table 400.5 lists the ampacity of flexible cords and cables based on their size and type. NEC Article 250 covers grounding and bonding, including requirements for grounding transformers and equipment. When selecting fuses, several factors need to be considered. The fuse must be rated for the voltage of the circuit, which in this case is 240 volts on the secondary side. The fuse must also be rated for the current that the circuit is expected to carry. This is typically based on the load connected to the secondary side of the transformer. The fuse should be sized to protect the transformer and the connected equipment from overloads and short circuits. A common rule of thumb is to size the fuse at 125% of the transformer's secondary current rating. For example, if the transformer's secondary current rating is 25 amps, the fuse should be sized at 31.25 amps. Since fuses are not typically available in fractional sizes, the next highest standard size fuse, such as a 35 amp fuse, would be selected. It's crucial to verify that the selected fuse size is appropriate for the connected equipment and complies with all applicable codes and standards. Time delay fuses, also known as dual element fuses, are often used in transformer circuits. These fuses are designed to withstand temporary overloads, such as the inrush current that occurs when a transformer is first energized, without tripping. This helps to prevent nuisance tripping while still providing protection against sustained overloads and short circuits. The overcurrent protection on the primary side of the transformer is also critical. This protection is typically provided by a circuit breaker or fuses in the primary circuit. The overcurrent protection should be sized to protect the transformer from overloads and short circuits in the primary side. A common rule of thumb is to size the primary overcurrent protection at 125% of the transformer's primary current rating. For example, if the transformer's primary current rating is 12.5 amps, the overcurrent protection should be sized at 15.625 amps. Since circuit breakers and fuses are not typically available in fractional sizes, the next higher standard size, such as a 20 amp breaker or fuse, would be selected. Again, it's important to verify that the selected overcurrent protection size is appropriate for the transformer and complies with all applicable codes and standards. When using a circuit breaker for overcurrent protection, it's important to select a breaker with an appropriate interrupting rating. The interrupting rating is the maximum amount of fault current that the breaker can safely interrupt. The interrupting rating of the breaker should be greater than the available fault current at the transformer's primary terminals. Available fault current can be calculated using various methods, including short circuit calculations or by consulting with a qualified electrical engineer. The type of cord used is also important. So cord is a flexible cord that is commonly used for portable appliances and equipment. However, it may not be suitable for all applications involving transformers. For example, if the cord is exposed to oil, grease, or chemicals, a different type of cord that is resistant to these substances may be required. Other types of cords that may be suitable for transformer applications include SGO, SGU, and SU cords. These cords have different insulation and jacket materials that make them more resistant to environmental factors. The cord should also be sized appropriately for the current that it is expected to carry. NEC Table 400.5 provides ampacity ratings for various types of flexible cords and cables. The cord should be selected based on its ampacity rating and the anticipated load. In addition to the cord, the connectors used to terminate the cord should also be selected carefully. The connectors should be rated for the voltage and current of the circuit and should be compatible with the type of cord being used. The connectors should also be installed properly to ensure a secure and reliable connection. Strain relief connectors should be used to prevent the cord from being pulled out of the connector. These connectors clamp onto the cord and provide a secure anchor point. The location of the transformer is also important. The transformer should be installed in a location that is clean, dry, and well ventilated. It should also be protected from physical damage. If the transformer is installed outdoors, it should be protected from the weather. The transformer should be mounted securely to prevent it from falling or being damaged. It should also be installed in accordance with all applicable codes and standards. Regular maintenance is essential to ensure the safe and reliable operation of the transformer. The transformer should be inspected regularly for signs of damage, such as cracks, leaks, or corrosion. The connections should be checked to ensure that they are tight and secure. The transformer should also be cleaned regularly to remove dust and dirt. Any problems should be corrected promptly. When working with transformers, it is important to follow all safety precautions. Transformers can be dangerous if they are not handled properly. Always disconnect power to the transformer before working on it. Wear appropriate personal protective equipment, such as safety glasses and gloves. Use insulated tools. Never work alone. If you are not qualified to work on transformers, hire a qualified electrician.